In this unit, we're going to be working with perimeter, area, volume, and temperature. In this lesson, we're going to look at area conversions and volume conversions. Okay, hi everybody. So in this lesson, we're going to be looking at area and volume conversions. Okay, so measurements, we're going to convert between units, but this time instead of it being just linear units, they're going to be area units and volume units that we're doing the conversions between. Okay, so just take a look here. We do not have conversions for square and cubic measurements. On your formula sheet, those aren't going to appear. We want you to know how to deal with that. Now, there are a couple of ways that you can do this. Okay, the first method is to convert all the linear methods measurements first to the other unit, and then calculate the area and the volume. Or what you can do here is, and this is kind of interesting too here, you can calculate the area or volume using the units that are given to you. But then when you go to convert it, so for example, if we were going to convert, let's say, meters cubed to yards cubed, okay, what I could do is I could calculate it in terms of meters cubed, and then look for my conversion factor, on this sheet right here. Okay, so I might go over here, meters and yards. So there's my conversion. 1 meter is 1.0936. So, and think about how I would convert it if it was just a linear unit. And at some point here, depending on how I do this, I'm going to, well, in this case, I would multiply by this 1.0936. But that converts a meter to a yard. And if I've got a meter this way, and then a meter this way in terms of your depth here, that means I've got these units cubed. What I would then do is I would multiply by this unit conversion cubed. Okay? I would just take this and I would cube that conversion factor and then multiply that through. Now, that might not make a whole lot of sense right now. Let's go through and do some examples, and hopefully you kind of get used to the idea. And I'm going to try to do, a couple this way and a couple this way so you get a sense of how it works. Okay, so the question says, what would the area be of a 16 by 10 inch rectangle in square inches? Okay, so our area here is going to be length times width, and so that's going to be 16 inches multiplied by 10 inches, and so that's easy. That's going to be 160 inches squared. Okay, so there's our area measurement there. But now, what if I wanted this to be in square feet? Okay, so here we go. First of all, the first thing I could do here is I could convert both the 16 inches and the 10 inches into feet. Okay, so let's do that first of all. So we know that 1 foot is 12 inches. So I'm going to try to figure out what my length is. So I'm going to cross multiply. So 16 times 1 is going to be 16. 12 times x is going to be 12x. And then I'm going to divide both sides by 12. And I am going to get, I'm going to pull up my calculator here, 16 divided by 12, and I get 1.3 repeating. Now, 1.3 repeating, and that is going to be feet. Now I'm going to kind of keep that in mind here when I go through and do my calculation here in a bit. The next thing I'm going to do is I'm going to convert the width. So 1 foot, again, is 12 inches. I know that. And I'm going to convert it again. X over 10 inches. And I'm just using x here. Actually, you know what? I'll tell you what. Let's make this a little bit more straightforward here, because we know what these are. Let's call this length, and this is going to be width. So 10 times 1 is going to be 10. 12 times W is 12W, and I'm going to divide both sides by 12. So my width here is going to be 10 divided by 12, and I get 0.83 repeating feet. So now my area is going to be 1.3 repeating feet multiplied by 0.83 repeating feet. So on my calculator, what I can do is I can actually go up and go press enter on that, multiplied by, go back up, press enter on that, and I get 1.1 repeating here, and I'm just going to convert that into a fraction. Oh, that did not do what I was expecting it to do, but that's okay. We can actually do it like this. I can say this is approximately 1.1 feet squared. Oh, you know what? Actually, you know what? I'm going to leave it like that. We're going to just take it to that point right there, 1.1 feet squared. Sorry, I know where we're going with this. I don't want to do anything more complicated with that at this point. Method 2 would actually be to go back up to this calculation and convert it here. So we've got our area is 160 inches squared. What I'm going to do with that is I'm going to introduce our conversion factor. Okay, so I want to get rid of the inches here, and I know, and we just did this over here, that 1 foot is 12 inches. Okay, I know that, and I'm putting the inches in the denominator here because I want the inches to cancel, and I want the feet to stay here, except that I've got an inches squared here, and I've only got inches here. So what I'm going to do is, for every dimension that I've got, length and width, I'm going to include another conversion factor. So this is my length conversion factor, this is my width conversion factor. And so what that means here is this is going to be 160 multiplied by 1 divided by 12, multiplied by 1 divided by 12. And we get, again, that 1.1 feet squared when all said and done. So there's two different ways that you can approach this problem. Granted, this one might look like it takes a little bit more work, but I think for a lot of people, this one's a little bit more straightforward in terms of the steps you have to take. This one is a bit quicker, but I think conceptually it's a little bit harder maybe to get your head wrapped around what's going on here with these two conversion factors. But just, again, the purpose of those two is because you're converting each dimension. Let's take a look at another one. A cube has side lengths 60 centimeters. What is the volume of the cube in square meters? Okay, so a couple of ways we can do this. First of all, let's figure out what the volume is of our cube here. So I know that the volume is going to be the side length cubed here, and if that's 60 centimeters, I'm going to go to my calculator, and that will be 60 cubed. Okay, so that's going to be 216,000 centimeters cubed. That's a lot. But at volume, the numbers in a volume calculation get big really, really quickly. So now there are two ways that I can do the conversion. The first way is to convert the 60 centimeters here. Now I know that because it's a cube, each side is going to be the same, so I only have to do this once. Okay, and I know with centimeters, okay, and if you're not remembering this, just pull out that little chart there. I know that we're going from centimeters to meters. I'm going from a small unit to a large unit, which means the number of the measurement there has to get smaller. Okay? If I'm looking at the same length, but I'm using a larger unit of measurement to measure it, then the number of those units is going to be smaller than it was when I had a centimeter. When I get a small unit, I have a whole bunch of them there. And remember, because it's two jumps along my chart here to go from centimeters to meters, I'm going to move the decimal 2 places to the right here. So our measurement here, our side length at 60 centimeters is going to be, move that over, 0.6 meters. And so now, when I find my volume calculation, that's going to be 0.6 meters cubed. And again, I go to my calculator. Okay, 0.6 cubed, and I get 0.216. So 0.216 meters cubed. So that's that first method. The second method, I'm going to go look at my volume here, 216,000 centimeters cubed. But this time I'm going to multiply by the conversion factor. Okay? So I know that in 1 meter there are 100 centimeters. Okay? And I put my centimeters in the denominator because I want them to cancel. This centimeters right here is in the numerator, so they'll cancel, but only one of them will cancel. This is my length. I got to do the same thing for my width. I got to do the same thing for my height. Now, the more comfortable you get with this, you'll notice that basically what I'm doing is I'm multiplying by the conversion factor cubed. But until you're comfortable with that, that's okay. Just think about it. I got to do it for each one of those dimensions here, length, width, and height here. So if it's area calculation, I only need to do it with the two of them. Volume, I got to do it with all of them. So it's going to be 216,000, okay, multiplied by 1 over 100, multiplied by 1 over 100, multiplied by 1 over 100. And just like before, I get 0.216, meters cubed. Sorry, I'll clean that up. Okay, let's take a look at another one. We're going to use the following diagram to answer the following questions here. So, and there's basically just a couple of questions. We're going to ask about the surface area. We're going to ask about the volume here. So determine the surface area of the cylinder in square feet and square meters. Now, what I'm going to do is I'm going to convert the inches into feet to do that calculation, and then I'm going to square the conversion factor to go from feet to meters, just so that you get a sense of kind of, again, both methods here. So in this case right here, 4 inches. I'm going to convert inches into feet here. So 1 foot is 12 inches. So, and let's make this, we'll call this R here. My radius is going to be 4 inches. So I'm going to cross multiply. 4 times 1 is going to be 4, and then 12 times R, and I'll divide. And when I divide that, 4 divided by 12 is actually going to be just 1/3. So it's going to end up being 0.3 repeating. Okay. Now I'm going to do this on my calculator because I want the decimal to be sitting there. But 0.3 repeating, 1/3 is equal to R. So it's 1/3 of a foot. Oops. And I'll put the unit in there. Now, I also want to get my height there. So 1 foot over 12 inches is going to equal the height over the 2 inches. So cross multiply, 2 times 1 is 2, 12 times h, divide both by 12. And that's going to be 1/6. But again, I want to do that on my calculator, so we're going to go 2 divided by 12. And there's our decimal, 0.2, okay, rounded. So now, determine the surface area of the cylinder in square feet and square meters. So, the surface area of the cylinder is going to be 2 pi r squared. That's the bottom circle and the top circle, the two bases there, plus 2 pi r h, and that's the lateral part there. In a previous lesson, we talked about it when you would, if you took a tin can and cut it down the side, you could unfold the side into a rectangle, where the length is 2 pi r, which is the circumference of that circle, and multiplied by the height. So in this case, this will be 2 times pi times 1/3 squared, there's my radius, plus 2 times pi times 1/3, and then the height was 1/6. Now, I've got these things sitting in my calculator, so here we go. 2 pi times 1/3, that's going to be squared, plus 2 times pi times 1/3, times 1/6. Okay, and so now, and you know what, just so that this is maybe clearer, I'm going to round that to the nearest hundredth, so 1.05 feet squared. Now that that's done, and I'm keeping that in my calculator for right now, now that that's done, let's put it into square meters here. So our surface area at 1.05 feet squared, what we're going to do here is I'm going to grab the conversion factor from feet to meters. Okay, so where are we at here? Feet to meters. Oh, right here. 1 meter is 3.2808 feet. Okay, so I want to get rid of the feet. So I'm going to put 1 meter over, and I saw it as 3.2808 feet. Now, I put the feet in the denominator because the feet squared here is in the numerator, and I want the units to cancel. But I've only got one of them here. So this is like my length. I got to have one here for my width. So I'm going to do this. I'm going to do this twice. So now on the calculator, I'm going to take that decimal that I just figured out, and I'm going to multiply it by 1 divided by 3.2808. Now, I could multiply this by another 1 over 3.2808, but because it's an area calculation, and you always do it twice for an area calculation, I'm just going to square that. And then we get approximately, and again, I'm going to round this to the nearest hundredth, 0. And that 7 is going to make the 9 go up here, so 0.10 meters squared. And our feet squared canceled. Now, determine the volume of the cylinder in cubic feet and cubic meters. Okay, so basically we would do the same sort of thing here. This is going to be a little bit quicker because I've already basically done the groundwork here. We've converted the radius into feet. We've converted the height into feet here. So the volume of a cylinder is pi r squared height. So it'll be pi multiplied by 1/3 of a foot squared multiplied by 1/6 of a foot. Whoops, I didn't put the unit in there. Hold on. 1/6 of a foot. Okay, so on my calculator, it'll be pi multiplied by 1/3 squared multiplied by 1/6. And again, to the nearest hundredth, that's approximately 0.06 feet cubed. Now, when I do the conversion, okay, I've got 0.06 feet cubed, but I want to convert that into meters cubed, so I'm going to have 1 meter over 3.2808 feet. Again, the feet go in the denominator because I want it to cancel with this unit up here in the numerator. And I'm going to have 3 of these factors, so I'm going to kind of speed this up a little bit. So I'm going to put the cube here now, so that I get my length being converted, my width being converted, and my height being converted. And so now I will take that number right there and multiply it by 1 divided by 3.2808 cubed. And we get this one. This one actually I got to go a little bit further than the nearest hundredth. The nearest hundredth is going to be like 0. So 0.002 meters cubed. Really small. Okay. Anyway, I hope that gives you an idea of how to do the conversions using your area units and your volume units.